Hello, and welcome to the 17th video in a series on the tabletop role-playing game Bunkers and Badasses. In this video, we'll be discussing damage calculations. This video will be mathematically intensive, but I'll try to break it down in simple, practical terms. When discussing a character, it's natural to wonder how much damage it can expect to do in a round and compare it to other characters. This can be described as damage per round, or DPR for short. We will express damage per round in relation to how many attacks can be performed in a round times the damage per attack. Usually, the number of attacks will be an integer, like 1 for most weapons, 2 when using Stoker weapons, or 3 when using Stoker weapons with skills and feats. We also know the expected value a dice will have when rolling a large amount of rolls. For a D4, it's 2.5. For a D6, it's 3.5. For a D8, it's 4.5. For a D10, it's 5.5. For a D12, it's 6.5. And for a D20, it's 10.5. We can use these expected values for dice to know the average damage per attack. For example, let's discuss the damage of a common Stoker shotgun at low levels. There is a miscellaneous accuracy modifier of -3 from the common Stoker shotgun, and we'll assume the player's accuracy and damage modifiers are 0. The number of attacks is 2, and the damage per attack is the chance for the attack to be in a particular accuracy range times the damage of that accuracy range. In our example, the chance to be in the lowest range is 30%, the next range is 40%, then 5% for the next, and finally 5% to roll a natural 20. These represent the coefficients of 0.3, 0.4, 0.05, and 0.05 respectively. These are each multiplied by the expected damage from the dice for their respective accuracy range. When rolling multiple dice, you simply multiply the number of dice by the expected value. This example also assumes you're at close range and get the +2 damage modifier for shotguns. Putting all of this together, everything becomes arithmetic and simplifies. Over the course of a campaign, the average damage per round will approach 15.95. Now let's describe a scenario that is a little more complicated. Normally the number of attacks is a small integer, but some skills and feats allow you to perform more attacks based on the chance to kill enemies. Depending on the kill chance, this can immensely increase the average number of attacks per round. The chance to do a particular number of attacks is found by multiplying the chance for the first number of attacks by the chance to stop the kill chain. For example, the chance of getting 5 attacks with a 70% kill chance is 0.7 times itself 4 times, because those continue the chain, times 1 minus 0.7 or 0.3, which is the chance to stop the kill chain. This calculated to 0.07203, or a 7.203% chance to do 5 attacks. If we take the sum of an arbitrarily large number of attacks and multiply each number by the chance it occurs, this becomes what is known as a geometric distribution. In the simplest case, it is expressed very nicely as 1 over 1 minus x, where x is the kill chance. For example, how many attacks will I expect to perform if the kill chance is 70%? By plugging the kill chance into the geometric distribution formula, it simplifies to 4/3, or 1.3 infinitely repeating. This means, on average, we do 1 to 2 attacks per round, but lean towards 1 most of the time. This average is our number of attacks per round and can be multiplied by the average damage per attack to obtain the average damage per round. All the different aspects of the attacks, such as the gun manufacturer, feats, and skills, can collectively contribute to computing the number of attacks per round. Things like using Stoker weapons or having the keep shooting feat will affect the numerator of the geometric distribution. You simply add the number of ways an extra attack is guaranteed to be made. Other things which affect the chance to create kill chains, and thus a geometric distribution, will add up to be the coefficient of the variable in the denominator. As a final example, let's find the average number of attacks per round if we're using a Stoker weapon, some feats or skills which give extra attacks, and feats or skills which have a chance to create kill chains. In this example, the numerator becomes 3 because we have the normal attack, an extra attack from the Stoker weapon, and an extra attack from the Keep Shooting feat. We are guaranteed to do a minimum of 3 attacks per round. We also have 2 sources of creating kill chains, namely from the Another feat and a class kill chain skill such as the Commando's Metal Storm skill. These 2 sources combine to make a coefficient of 2 for the variable in the denominator of the geometric distribution. This all comes together to say the number of attacks per turn is represented by 3 over 1 minus 2x. This is a lot of math. Players absolutely don't need any of this for good role-playing. This video is meant for those passionately curious players who like to know how things work under the hood. I'd also like to thank user AradiaBot on the Learn Math subreddit for clarifying the formulas for me. In the next video, I'll discuss my personal observations and recommendations. Thanks for watching.